talk about the differential equation and its many aspects. Differential equation is too much important in our daily life, especially in wide variety of disciplines like physics, chemistry, mathematics, biology, economics, etc. Actually, differential equation is a relation among variables, function of variables and its derivatives. Differential equations are mainly divided into two classes. One is ordinary differential equation and other is partial differential equation. What is ordinary differential equation? Ordinary differential equation is a function among an independent variables, function of independent variables and its derivatives. And other is partial differential equation. What is partial differential equation? Partial differential equation is also a relation among some variables, an unknown function of these variables and its partial derivatives. Now I shall show you the general form of first order ordinary differential, general form of ordinary differential equations. This is the general form of ordinary differential equation, which is function of, that is f of x, phi dot x, phi double dot x, phi n x equal to 0. Here x is independent variable, phi x is the function of independent variables, and phi dot x, phi double dot x, phi n x are the derivatives of phi x in several orders. This is the general form of ordinary differential equations. Other is partial differential equation. Here, this is the general form of first order partial differential equation, which is function of x1, x2, x3, xn, w, del del x1, del w, del x2, del w, del xn equal to 0. Here, x1, x2, xn are the independent variables. W is an unknown function of independent variables, and del w del x1, del w del x2, del w del xn are the first order partial derivatives of w with respect to x1, x2, xn. This is the general form of first order partial differential equation. Differential equation emerges from the mathematical formulation of natural phenomena like population growth, radioactive decay, wave theory, etc. Differential equation takes a prominent role in modern technology also. The mathematical formulation of natural phenomena is mostly based on differential equation. The differential equation is highly essential for the progress of several subjects like physics, chemistry, engineering, technology, etc. Now, I shall take a discussion about the many application of differential equation in several subjects. Firstly, in physics, it has vast applications there. Many laws in physics are largely dependent on differential equation. Here, I shall take some example of application of differential equation in physics. Firstly, this is the Newton's second law of motion, which is designed as m d2 s dt2 equal to m, where m is the mass of the particle, x is the displacement of the particle at time t, and f is the applied force. This is the second law of motion, Newton's second law of motion, which is a second order ordinary differential equations. Other example is in RLC circuit, which is also a second order ordinary differential equation, which is L d2q dt2 plus R dq dt plus dq by dt plus q by c equal to epsilon 0 cos omega t, where L, R, I, Q, omega have their usual meanings. This is the second order ordinary differential equation in physics. And other example is Schrodinger equation, which is the most important equation in quantum mechanics, which is minus h square by 2m del square psi plus v psi equal to e psi, where del square is the Laplacian operator which is summation of second order partial differential operator with respect to three variables x, y, z. That is del square equal to del 2 by del x2 plus del 2 by del y2 plus del 2 by del z2. This is a second order partial differential equation which is used in Schrodinger equations. So there are numerous applications of differential equation in physics. For mathematical formulation of chemical reactions, differential equation is indispensable. For example, this is a differential equation which is used in second order chemical reaction, which is ddt of concentration of A equal to minus K into concentration of A, that is A is the reactant, square. This is the application of differential equation in chemistry. Also, after solution of this equation, we can determine the exponential decrease of the concentration of the reactant A. This is the application of differential equation in chemistry. There are adequate applications in the analysis of theories of economics. For example, this is a differential equation which is used in economics. This equation is ddt of xt equal to g of xt, where xt is the GDP, that is gross domestic product at time t, and g is the growth rate. Also, if we solve this differential equation, we are able to conclude about the exponential decrease or increase of the gross domestic product. So there are many applications of differential equation in economics also. To model and understand the biological phenomena like predator-prey interactions. The predator-prey interaction is mathematically explained by the predator-prey equations. This equation is this. This is the predator-prey equations. These are two differential equations which is used in predator-prey equations. The equations are ds dt equal to alpha x minus beta xy, dy dt equal to delta xy minus gamma y, where x is the number of prey, y is the number of predators, alpha, beta, gamma, delta are parameters, 4 parameters. So these are the differential equation which is used in biology. There are so many applications of differential equation in biology. So differential equation describe most of the phenomena in real world. In some respects, also differential equation predicts what may happen in future. The advancement of our civilization enormously depend on the application of differential equation. Thanks for watching this video. See you later.